to discuss the past paper topical questions of forces, density, and pressure from the year 2024. So let's begin with the first question. A solid sphere which is less dense than the water is held completely immersed in the water a few meters below the surface. The density of the water is uniform. The sphere is released. So it's released at some point, and immediately after release, the sphere rises. And you have to explain which row describe the change in magnitude of upthrust and the resultant force. So let's try to understand the scenario first. Let's suppose this is the water in which you have a solid sphere at this point and you held it stationary. Okay, so there will be a weight acting on it downward. There will be a upthrust force acting on it. Okay, they both are constant. So the upthrust, because upthrust force we know is depends on density, gravitational field strength, and the volume. As all of things are constant, so upthrust remain constant. So we have to choose between A and B. So let's discuss about the resultant force. When this start moving up, when it move up, it will speed up. So when it speed up, there will be a drag force on it that will be increasing. So drag force will act opposite to the motion. That is a drag force. Okay, that will keep on increasing as the it's speeding up. So resultant force, as we know, it's moving up. So upthrust is more. Upthrust minus drag plus weight. Okay, weight is constant. This thing is a point of interest. The drag force, it will keep on increasing. As this factor increase, the resultant force will decrease. Okay, so it will be A. Okay, let's move to the next question. A uniform bar of weight 200 Newton and a length of 4 meters freely hinged on a wall at one end. The bar is horizontal and is held in equilibrium by a cable attached at a distance of zero point 0.5 as they are showing here. Okay, this is the cable from which it is attached. The cable is at an angle of 35 degrees to the horizontal. This is horizontal. What is the tension T in the cable? You have to find this thing. Okay, so to find tension as it is in equilibrium, it is at rest. So we know clockwise movement must be equals to anti-clockwise movement. Okay, so what are the forces acting on it? One is this force, that is a tension. Other force will be the weight of the object, weight of the this bar. As the bar is uniform, it's given in the question, it's a uniform, its weight is 200 Newton. So for a uniform bar, the weight always act at the center. So let's suppose this is the center, there will be a weight of 200 Newton acting. And as it is a total length is 4, so this distance will be 2.0 meter from the pivot point, right? Okay, so we know this movement will be anti-clockwise because of the weight. There is a tension that is also exerting a movement on it, applying a force on it. So we have to resolve this thing. It's one component is this, other component will be like this, but this will not produce any movement. So we are interested in this thing. So it will be T sine of 35. So this will produce a movement in clockwise direction, and as the total length is 4, this is zero point 0.5, so this distance will be 4 minus zero point 0.5, this is 3.5. Okay, so its distance is 3.5 meter from the pivot point. So the clockwise movement will be force, that is T sine 35, into the distance, that is 3.5, that is equals to anti-clockwise movement, that is because of the weight 200 multiply with the distance, that is 2. So T will be equals to 200 into 2 divided by sine 35 multiplied by 3.5, and when you do the calculation you will get answer 200. Okay, so it's option C. In the next question, the diagram The diagrams all show a pair of equal forces acting on a meter rule. Which diagram show force that produce a couple and a zero resultant force? Okay, for couple, we know forces should be equal and opposite in direction, right? So this will not be a movement couple. This can be a couple. They are equal and opposite. Okay, why this is not a couple? Because the line of action of force is same. So when the line of action of force is same, this will also not a couple. It will not produce any moment. That force is zero in that case as well. But there is no couple. There is no movement in that case. Okay, so this will not be option. Option B is correct. Okay, so in question, which single condition must apply for an object to be in equilibrium? Okay, for an object to be equilibrium, we know the resultant force acting on it must be zero. Okay, so it can be stationary or it can be moving with a constant velocity if the resultant force is zero. So the basic condition is resultant force must be zero, acceleration must be zero. Okay, okay. So in the next question, a kite is in equilibrium at the end of the string as shown. The kite has a three forces acting on it: the weight, the tension in the string, and the forces from the wind. Which vector diagram represent the forces acting on the knife? Okay, as this thing is in equilibrium, so we have to look at the forces, those are cancelling each other. Okay, so as we have discussed in the previous questions, the forces, when there are different forces, if they are in a cyclic shape, they will cancel each other. So if you see this thing, it's moving like this, its arrow is moving down there, right? This is its arrow, then it's moving there, okay, and it's moving there, and it's attaching at this point. So this is the cyclic thing, right? So this will be a zero resultant force. If you see in B, this thing is moving like this thing is moving like this, but there is something wrong. It's not cyclic. Okay, it will not give you a resultant zero. Same is with this case. This will not give you a resultant zero. Okay, you can check it anyway. So A is the right option. Okay, and the next question, four forces act about a point P. This is a point P. So this will be the pivot point. The forces act in the same plane and produce no resultant movement about point P. What is the length xy? You have to find length xy, and what we know there is no resultant movement. So we can apply a principle of movement. Total clockwise movement must be equals to total anti-clockwise movement. Okay, so what are the forces we have? If you see this force, this will produce a clockwise movement, this will produce anti-clockwise movement, this will produce clockwise movement, and sorry, this is anti-clock, this is also clockwise. Okay, basically this is x shaped like bar, it's attached with each other. If you apply a force on any of the point, it will produce a movement. So there are two clockwise, two anti-clockwise movements. Okay, so this is all right. We know this force and we know this distance. We can calculate this moment as well. We know this force and this distance, it's a perpendicular distance basically. But there we have to resolve this thing because we need the perpendicular distance between the force and the pivot point. So if this is the force, what I can do, I need this distance, right? The distance between this and this one thing. Okay, I can resolve this force as well. It's my choice. I can resolve this distance factor or I can resolve this force. Okay, so if I'm considering this force, I can resolve this thing. I need, what I have to do, I have to look at the line of action of force and I have to draw an imaginary line parallel to the line of action of force passing through the pivot point. Okay, so these are the two lines. What distance we need? We need this distance. This distance will be multiplied by 5 to give you the resultant moment, give you the moment of this force. Okay, same is the case with this thing. So if this is the force, this is a line of action of force. You have to draw or imagine a line parallel to this line but passing through the pivot point. This is the second line. So this distance will be considered for this movement. Okay, so let's do this. I'm going to find out this thing first. Okay, if this point is, this is P, so I'm going to call this thing XP. Okay, if this is 60, this will also be 60. Okay, so this thing will be equals to XP sine 60. Okay, let's do the same thing with this. If this is the force and I need, this is the line parallel to the line of action of force passing the pivot, we need this distance. For this distance, what I have to do, I can imagine it like this whole thing I can call it yp. This point is p, right? This is p. So this angle is 60, so this angle will be 30, I can say. Okay, so if this is 30, this will be yp cos of 30. Okay, so now I can find the moments. For this moment, this moment is 5 into xp sine of 60. Okay, let me use the different colors. And for this moment, the force is 5, so it is 5 into, distance is this, yp cos of 30. Okay, and for moment of this force, I can write as 6 into 3, simply the distance from the pivot. And for moment of this force, I can simply write 6 into the distance from the pivot to this, that is 7. It's given. Okay, so let's make the equation. Total clockwise movement, clockwise, is 6 into 7, plus the second clockwise movement is 6 into 3. That must be equals 20 clockwise movements, that is 5 into xp sine of 60 plus 5 into yp cos of 30. Okay, okay, so what we can do, if you find cos of 30, let me calculate. Cos of 30, it will give me 5 into xp, 5 into yp. Cos of 30 is 0.86, and sine of 60 is 0.86. 0.86. Okay, on the left side, 6 into 7, 42, plus 6 into 3 is 60, so it is 60. So 60 is equals to 5 into 0.86 will give you 4.3 xp, plus 5 into this thing, it's 4.3 yp. Okay, so 4.3, 4.3, you can take the common. 4.3 xp plus yp. So if you see, this is xp from this point to this point, and from this point to this point, this is yp. So if you add both of them, that will give you xy that you have to find. So 60 is equals to 4.3 xy. Xy is 60 divided by 4.3. So when we find 60 divided by 4.3, that will give us 13.9 5, that is approximately 14. So it's option C. Okay, so in the next question, a rectangular block of lead of density this has sides of length. You have given the three sides. What is the maximum pressure the block can exert when resting on the table? Okay, so we know P is equals to F over A. So I can say pressure is inversely proportional with area. For maximum pressure, we need minimum area. Okay, so minimum area will be of the sides with the minimum length. So 15 is the largest. So minimum area will be by 12 into 10. Okay, the smaller length you will multiply with this, that will give you 120 centimeters square. So you have to find the maximum pressure. So pressure is force over area. Okay, we don't know the force. We know it is equals to weight, that is mg over area, right? Okay, we don't know the mass, we know the density. We know density is mass over volume, so mass is density into volume. So you can put density into volume into g, divide by a. Okay, now you have all the values you can put there. It will give you density is 1.13 10 raised to power 4. Okay, and for the volume you have to multiply 12 with 15 with 10 with g 9.81, and area you have to multiply what we have multiplied 12 and 10. Okay, so you can simplify this thing. This will cut with each other, so multiplying this you will get answer 116,627.95, that is 16.6 kilopascal. Okay, it's option D. In question 9, which statement correctly describe a couple? Couple is a couple is when two forces of same magnitude but opposite direction act on the object, and they should produce the movement, right? They should produce the rotation. So their line of action should not be same. So a couple is a pair of forces that act to produce rotation only. Yes, they only cause the rotation. They will not cause any linear motion. Okay, because resultant force will be zero. Okay, in question 10, a uniform beam of mass 1.4 kg is pivoted at point P. The beam has a length of 0.6 meter and P is a distance of 0.20 meter from one end. Load of 3 kg and 6 kg are suspended at a distance of zero point 0.3 and 0.15 meter from the pivot. What is the torque that must be applied to the beam in order to maintain it in equilibrium? Okay, so you want to maintain it into equilibrium, you have to find the required torque. So let's first find what amount of clockwise movement is there and what amount of anti-clockwise movement is there. Okay, so as we have um, two masses, this mass will produce clockwise movement, this mass will produce anti-clockwise movement, and there is a weight of the bar as well that is also producing a anti-clockwise movement. So clockwise movement is force multiplied by the distance. Force will be equals to weight of the object. So weight is 6 into 9.81, and the distance from the pivot is given 0.15. Okay, for anti-clockwise movement it will be when I consider this thing, the weight of the object, weight of the rod beam, it will be 1.4 into 9.81 multiply by the distance. Okay, so what is the distance? The total length is mm, 0.6, and if this should be at the center, right? So this should be 0.3 from this point to this point. So this is 0.3, and this is 0.2, so this will be 0.1. Okay, so it will be multiplied by 0.1 plus the moment because of this mass, it will be 3 into 9.81 into the distance, that is 0.35. Okay. Okay, so what we have to do, we have to subtract anti-clockwise movement with clockwise movement to find the difference. So when you do that, you will get 2.844. So that is the difference in both the movements. So if you provide that movement, that this beam will be balanced. It will be in equilibrium. So it's option D. In the next question, the diagram showed three rigid objects P, Q, and R being subjected to different combination of forces. Which objects are in equilibrium? Okay, for equilibrium, the forces should cancel and the moment should be zero. So let's check them one by one. If you see, if I simplify these two forces, it will give you 10 Newton here. If I simplify these two forces, it will give you 10 in this direction. Okay, so it will not move, but it will rotate. So there will be a couple produced on this thing. So this thing is not in equilibrium. Okay, it will start rotating. Okay, if I resolve this thing, I can simplify these two. If I simplify these two, they are anti-parallel. This will give you 20 Newton. If I simplify these two, this thing will give you in this direction 20 Newton. Okay, so these both 20 Newton, 20 Newton will have some resultant force. So this thing will also move. It will not be in a equilibrium. Okay, so what about these? If this is 100, this will be 50 cos of 30. This will be 50 cos of 30. Okay, so they will be added, and if they are equals to 100, then they can be balanced. Let's check. 50 into cos of 30, it will give you 43. 43.3. This is also 43.3. So their addition will be 86 something, and this is 100. So this will not give you a resultant 0.4. So this is also not in equilibrium. So it's option none of them. Okay. In question 12, the diagram showed two liquid labeled P and Q that do not mix. The liquids are in equilibrium in an open U tube. Three equal distances x are labeled. What is the ratio of density of P and density of Q? Okay, so their height depends on the pressure of the liquids, right? So we know that the pressure of the liquid is rho g h. H is the depth, right? It is the depth. So for P, pressure of P should be equals to pressure of Q. That is the reason why they are stable like this. So for pressure of P, I can write density of P, G, and depth of P. If you see the depth of P, it's starting from here and it's ending at this point. Okay, so this is the depth of the liquid at this point. So this thing will be equals to 2x. For depth of Q, density of Q is rho Q, let's call it like this, G, and the depth is, for the Q, this is the difference, it's 1x, right? So it is the x. Okay, so when we simplify them, this g cancel out with this g, this x will cancel out with this x. So what we have to find, density of P over density of, so density of P over density of Q will be equals to, there is 1 and this 2 will go on the right side, it will give you 1 by 2. Okay, so it's option A. Okay, so in the next question, A thin horizontal plate of area 0.036 meters square is beneath the surface of liquid of density 930 kg meter cube. The force on one side of the plate due to the pressure of the liquid is this much. Okay, what you have the density, you have the area, you have the force. What is the depth of the plate beneath the surface of the liquid? So you have to find the depth, right? So we know we don't have the pressure, but we have the force. So for the force, we can write rho gv. Okay, and we don't have the volume, but we have the area and we have to find the depth. So it can be written as a into h. Volume is area into depth. So as we have to find the depth, so h is equals to f divided by rho ga. F is 290, density is 930, g is 9.81, this is 0.036. Sorry, let me write it here, 0.036. So calculating this, we will get 0.882. So it's option A. Next question. An isolated object of negligible weight is acted on by two coplanar forces of the same magnitude. In which diagram is the object is in equilibrium? Okay, for the equilibrium, um, equal forces, opposite direction, and line of action is same. So there will be no resultant force, no resultant movement. So this thing will be in equilibrium. Okay. In option B, if you see, it will produce a couple. The forces will be cancelled, but movement will not cancel each other. In option C, there is a resultant force, and in option D, there will also a resultant force acting on it. In the next question, a uniform beam PQ rests horizontally on a support at point S. Here we have a point S. A rope is attached at one end of the beam. Here, the rope is at an angle of 60 degree to the vertical and exert a force of F in newtons on the beam. What is the moment in Newton meter of the force F about the point S? Okay, so you have to find simply the moment because of force F at point S. So simply what you have to do, this force at an angle, you have to find its components. If I find its component, one component will be like this, other will be like this. This component is irrelevant because you see this component is passing through the pivot point. So when it passes the pivot point, it will not produce any movement. Okay, so we are only interested in this component. So this will be F cos of 60. So force will be F cos of 60, and the distance is, we have to take this distance. Okay, so this will be 2.5 minus 0.3, so it will be 2.2. Okay, so when we multiply them, it will give you cos 60 multiplied by 2.2, it is 1.1, and F will be there. It's option A. The diagram shows the dimension of cord used to project a stone. The tension in the cord, that is T, is pulled into the shape as shown below. Okay, so this is the stone, and you are pulling the stone backward, and this is the cord that will be in that shape because of the pull on the stone. Which force does the elastic cord exert on the stone? Okay, so there are two tensions, two forces, and you have to find the resultant of them. So we have to resolve them. If you see this tension will have two components. One will be in that direction and one will be in this direction. Okay, so if this is theta, this is some angle, so this component will be t cos theta, and this will be t sine theta. Okay, if I look at the force, that is this tension, this one, it also have two component. If this is the angle theta, This thing will be the t cos theta, and this thing will be the t sine theta. It will be in this direction. So if you observe them, they both are these two, this one and this one. They both are in opposite direction and they are equal. So they will cancel out each other. Okay, so we can simply ignore these components because they will not make any difference. And as these two are in the same direction, they will be added. So t cos theta plus t cos theta will be the resultant force that we have to find. Okay, so how we can find theta now? If you look at this shape, this thing is making a triangle whose this angle is we call theta, and this total is 16. So from this to this thing will be 8. So this is 8. This side is 10, 10. Okay, and we don't know this side, so we can write down the theta with the help of these two sides. So as we know, cos theta can be written as base over hypotenuse. Yes, we know this thing as well. This is 6 centimeter. So cos theta is base over hypotenuse. So this will be 6 over 10. Okay. So we can directly write down these values there. So putting this thing here and here, you get F is equals to T into 6 by 10 plus T into 6 by 10. That will give you 6T by 5. Okay. So this is the option B. In the next question, two forces act on an object. Which diagram represent a couple? Okay, for a couple, forces should be equal and opposite, and the line of action should not be same. So they are equal but not opposite. They are equal and opposite. So it's correct. This is not correct. This is not correct. Okay. So it's option B. In the next question, the diagram shows a uniform rod XY that is freely hinged to a vertical wall at Y. So this is the rod, this is the X, this is the Y, and it is pivoted at point Y. Okay. The rod is at an angle of 60 degree with the wall. So this is the angle that is given. A force F act at an angle of 30 to the rod. They're talking about this force. The rod has a weight of 3 Newton. They have shown it's acting at the center and is in equilibrium. It's an equilibrium mean what they are telling you that clockwise movement will be equals to anti-clockwise movement. Okay, this is the hint they have given you. What is the magnitude of force F? So you have to find this force. Okay. So if you look at the diagram, for the moment what we need the force multiplied by the perpendicular distance between the force and the pivot point, right? So there are two ways. You can either resolve the forces or you can resolve the distances, okay, to find the moment. So forces are, one force is this one and the second force is this one. I'm going to resolve the forces. Okay, so if you resolve this weight thing, this will be the 3 cos theta if this thing is theta. Okay, and there will be the second component, this will be like this will be the 3 sine theta. Okay, if you look at the 3 sine theta, its line of action of force is passing through the pivot point, so it will not produce any movement. So you can simply ignore this component. Okay, simply because it will have no contribution in the movement. Okay, and when we look for the force F, it will also have two components. One will be like this, other one will be like this. Same, if you see this thing, if as theta is here, this is f cos theta 30, and this will be f sine 30. This 30 is given, right? So if you see this thing, its sign of action is also passing through the pivot point. So you can simply ignore this component as well. So I'm going to remove this one. Okay. So now we have the relevant components that we have to consider. So I'm going to only highlight those that we are going to consider. One is this force, and the second force is this, the component of that thing. Okay. And this is the angle theta. Okay. So what this theta will be, let's work out this thing. We need this theta, right? So if you consider this whole thing, what I can do, I can draw a line here like this. So this whole thing is making a triangle, right? This is a triangle that is made here. This is 60, this is 90. So what this will be, this will be 60 plus 90 plus x should be equals to 180, you know, the total angles of the triangle. So this thing will also be equals to 30. And as we have discussed before, if this angle is 30, this theta that we have written here, okay, this is from the dynamics topic, this will also be equals to 30 degree. These two angles will always be same. So this can be written as 3 cos 30. Okay. So now what we need the distance from this point till this point, the pivot point, right? To find the moment. Let's work out this thing. The total length of the rod is it given to us? No, it's not given. Let's suppose, so let's imagine this whole length is from this point to this. Let's call it x. So from this point to this point, this will be x by 2. Okay. So clockwise movement must be equals to anti-clockwise movement. Okay, this will produce anti-clockwise and this will produce clockwise movement. Okay, so this is the clockwise and this will produce anti-clockwise. So clockwise movement force is F into sine of 30, multiply the distance is from the force till the pivot point, that is x, is equals to anti-clockwise, this is the force, and the distance from the force till the pivot point, this is the pivot, so this is x by 2. So this is 3 cos 30 multiplied by x by 2. Okay, so this x will be cancelled with this x, and you have to find f. So f will be equals to 3 cos 30, and there is a 2 as well, and sine 30 will come from the left side. Okay, so this thing will give you 2.6 Newton. So it's option C. In the next question, what they're telling, water has a density of 1.0 gram per centimeter cube. So you have given the density of water, let's call it rho W. Glycerine has a density of 1.3, so it's the density of glycerine, let's call it rho G. A student made out of volume of glycerine into the container, so let's call this thing volume of glycerine, Vg. The student add water to the cylinder container to make a mixture of water and glycerine. Assume that the total volume of water and glycerine does not change when the two liquids are mixed. Which volume of water need to be added to a mixture of a density this is the total density. You have to find total volume. Okay, so let's work out this thing. You have the total density, So total density, as we know, density is equals to mass or volume. It will be total mass over total volume. Okay. So how the total mass can be calculated? It will be a sum of mass of glycerine plus mass of water, and total volume will be mass volume of glycerine plus volume of water. Okay. So what we have to find? We have to find volume of water, right? This thing we have to find. Okay, we don't have mass of either of one, so we can change the mass into another form. We know mass is equals to density into volume, right? So this can be written as mass of glycerine can be written as density of glycerine into volume of glycerine plus mass of water can be written as density of water into volume of water, and it is this. Okay. So if you notice in this thing, we have we already know the total density. We know density of glycerine, volume of glycerine, density of water. We know the volume of glycerine. Okay, so what we don't know, don't know the volume of water. So there is only one unknown. Now it's simple. You just have to simplify this equation. Let's call this VW as x, and that you have to find. Okay, so let's write down the equation. It is rho t is equals to, okay, let's um, rho g vg plus rho w into x divided by vg plus x. Okay, now you can put the values. When you put the values, it will become total density is 1.1, is the density of glycerine is 1.3, volume of glycerine is 40, plus density of water is 1 into x divided by volume of glycerin is 40 plus x. Okay, so now we just have to simplify this thing. 1.1 40 plus x will be multiplied, it will be equals to 1.3 into 40 plus 1 into x is x. Okay, now you can open this bracket, so it will be 40 into 1.1, that will give you 44. Okay, plus 1.1x is equals to 1.3 into 40, it will give you 52 plus x. Okay, take the x on the left side and take this thing on the right side. So 1.1x minus x is equals to 52 minus 44. It will be 0.1x is equals to 8, and x will be equals to 8 divided by 0.5, that will give you 80 centimeter cube, because it's the volume. Okay, that's option D. In the next question, the diagram shows the view from above of a sprinkler system used to water a garden. The sprinkler consists of a tube of length 0.15 as shown. The tube is pivoted in the middle and spins in the horizontal plane as it lets out the jet of water from each end. The two water jets are in opposite direction to each other. Each water jet exerts a force of this. And what is the magnitude of the torque on the tube from the water jets? Okay, so these are the two forces are equal, it's given, and they're in opposite direction, so this thing is making a couple. So we know couple is simply force multiplied by the distance between the two forces, that is equals to 0.15. So it is simply force is 3 newton given 0.15, that is a distance, so it will give you 0.45 newton meter. Okay.